Hello, today we're going to be graphing with polar coordinates. In the past, we graphed with rectangular coordinates. Their ordered pair looks like an X and then a Y, and their graph looks like an X-axis and a Y. So what do polar coordinates look like? First, let's look at their ordered pairs. Their ordered pair looks like r theta, where r is the radius and theta is the angle. So if you recall, any xy point can also be rewritten using the radius length and the angle measure. So those are polar coordinates. But if we have a new ordered pair, it also makes sense that we have a new piece of graph paper. Our polar graph paper looks a little bit different. If I can get there, it looks like this. Here's our polar graph paper. And in here you'll see that there are different angles. These are our different theta values. And each ring would be an r distance. And you can make it like 1, 2, 3, 2, 4, 6, just as you would for a scale with any regular piece of graph paper. When you're graphing in rectangular coordinates, we make it an out table, and we pick points, then we plot those points. You can apply that same theory to polar coordinates, but instead our in-out table is going to be r theta. And it's going to be, typically, r is your independent variable, and theta is typically a dependent variable, can rearrange. So let's try graphing. First, we're going to take this polar equation, r equals theta over 20. I would start by picking good theta values. In this case, theta is your independent variable. I'll treat it that way. 0, 20, 40. These are all good values because I can easily divide them all by 20. So 0 divided by 20 is 20. 20 divided by 20 is 1. 40 divided by 20 is 2. 60 divided by 20 is 3. I can keep on going, or I can show you my in-out table. When you're plotting your points, first you have to decide on a good scale. Given the size of my graph paper, I'm going to make my scale 2. So, of course, I have to realign. So when I make my scale 2, I'm just going to make note on my paper that my scale is 2. So each ring will represent 2. So at 0, it's 0. At 20 degrees, I'm going to go out to 1. Then at 40 degrees, I'm going to go out to 2. I'm a little bit misaligned. Pause for a quick moment. At 50, at 60, I'll go out to 3. At 80, I'll go out to 4. And then I'm going to keep going along with my in-out table. I started to notice a pattern, so I'm filling in my points a little bit quicker. And once I run out of space, I'm going to kind of eyeball it. So my polar graph is going to look more like a seashell pattern. Say I want to graph this one. It would be very, very similar. I would choose probably 0 and multiples of 50 to create my graph. If I want to graph r is 4, well, what is a good r value? Or should I choose theta? Let's do it. Start with theta. Say theta is 0. What's r? It's 4, because r is 4. What if theta is 20? R is 4. What if theta is 40? R is 4. And then you might notice a pattern. For my scale, I'm going to make it once. So if I start plotting at 0, I'm at 4. At 20, I'm at 4. At 40, I'm at 4. Oh. I start connecting my values, and I have a circle. So our next task would be to graph polar coordinates on your own. There is one more type of graph that I do want to mention. Say you want to graph that was theta equals 20 degrees. If you're graphing something like that, on your in-out table, I pick theta, I'll start with an r value. Say r is 2. What's theta? 20. Say r is 4. What's theta? 20. Then if I go back to my graph paper, I'm just going to take this random piece. When r is 2, theta is 20. When r is 4, theta is 20. It would just be a straight line coming out. So it's kind of like three different ways, three different kinds of graphs that you would see when you're graphing